Good day, students. Today we want to solve problem on equilibrium of forces involving balancing of a meter rule. Now what you need to do is to make sure that you read the question appropriately. Now let's see, it's a very simple question. We have seen some students on the previous the upload I solved on a question based on this equilibrium of forces. The student asked me to upload a similar question on that for better clarification. Now what we need to do now is to read the question appropriately. A meter rule is found to balance at the 51 centimeter mark. Let's assume this is our meter rule. Okay, balance at the 51 centimeter mark. Meter rule, the center of the meter rule is uniform meter rule is 50 centimeter. The whole length of the uniform meter rule is 100 centimeter, and we now assume that is balanced at 51 centimeter mark in the question. Normally the center of the meter rule is 50 centimeter, but here we are told that the meter rule is balanced. You can see the full stop is balanced at the 51 centimeter mark. Okay, the center of the meter rule where it's been balanced. Let me say you have a pivot like this. You have the whole length of the meter rule to be 100 centimeter. We're told that the balancing point where the ruler balance is at the 51 centimeter mark. Okay, that's where the weight of the ruler will act. That's where the weight of the ruler will act at this point. The weight of the ruler will act at this point as the mass mg of the meter rule. Okay. Now we're told the meter rule is found to balance at the 51 centimeter mark. Okay, that's the point where the mass of the ruler will act. Okay, continue to 100 centimeter, but we're interested where the weight of the meter rule will act. Is that okay? Now let's now continue reading. When a body of mass 65 grams is suspended at the 10 centimeter mark, the balance point is found to be at the 25 centimeter mark. Again, when a body of mass 65 grams is suspended, when you suspend the mass at this point 10 centimeter, you suspend the mass 65 grams. When you suspend it, we are told that the balance point is found. It's now moved from the center and move to another point. The balance point is found to be at the 25 centimeter because of the hanging of the 65 gram mass at this point. The balance point now. Okay, We are now told to find the mass of the ruler. The mass of the ruler will be at this point. But we have to know this distance. The first part. Let's solve the first part now. The mass of the ruler is 51 from the 0 point. This is 0 centimeter. It's 51. That's 51 minus 25. 51 minus 25. You have this. This point you have 51. 51 minus 25 centimeter. This point, all you have is that 51 minus 25. Follow on to this, we have it 6. Yeah, left it for 2. That's 26. Here now is 26 centimeter. 26 centimeter. From here to here is 10 centimeter, while from this 0 point to the pivot fulcrum is 25. 25 minus 10, we are in 15 centimeter. 15 centimeter. Based on what we have now, we have the clockwise moving like this, clockwise moment moving toward the right, anti-clockwise moments, anti-clockwise moments. Okay, and the condition for equilibrium says clockwise moments equals to anti-clockwise moments. And the moment of force, don't forget the formula for moment of force. Moment of force equals force times perpendicular distance. Okay, now you're having the mass here. It's not yet weight, you are dealing with the mass. Also, we are dealing with mass, you can see in the question. Okay, now have mg, mass in gram, clockwise, times the distance here from this mass to the fulcrum, 26, equals anti-clockwise, that's 65 times 15. 25 times mg, that's 26 times mass in gram, that's 26 mg, equals to 65 times 15. Divide both sides. Divide both sides by 26. You have 26 mass in gram equals 65 times 15. Divided by 26. Divided by 26. 26 cancel 26. Mass in gram equals, when you multiply it and divide, okay, let's do the multiplication. 65 times 15. 5 times 5, 25, carry 2. 6 times 5 times 6, that's 30, plus 2, that's 32. 1 times 5, 5, 1 times 6, 6. 5, 7, 9. That's 975 divided by 26. I do that appropriately. You have 37.5 gram. 7.5 gram. This is the first part of the question. Let's move to the second part, which says the distance of the balance point from the zero. And I'm looking for the distance of the balance point from the zero. You can see in the first question, we know we are given the distance of the balance point from the 0 when the mass 65 gram is being hanged. Okay, now we still have the mass is 0 centimeter, 0 centimeter. From 0 centimeter to where the mass of the meter roll acts measured. Okay, that's mass in gram. That's the center of the meter roll before any mass is being hanged. That's where that's 51 centimeter mark. That's the center of the meter roll where the mass is being hanged before any mass is being hanged. Okay, you can see the distance of the balance point. We got this one from the question. The distance of the balance points, we have to look for the distance of the balance point from the 0 end. Okay, if the body were moved to the 22 centimeter mark, now the same body, which is 65 gram, will move to the 22 centimeter mark. The balance point will now shift from the center, having the same mass, 65 gram. Okay, now from here we want to know the balance point from this 0 end. That's what we need. Let's take it as y. Here now we're having 51 minus from the starting point to the center of the meter row. You have 51. Here now we'll have a 51 minus y. When you remove y from 51, you have the distance. Okay, here now will now be y minus 22 to give us this distance. Y minus 22 y minus 22 give us that. Now don't forget our clockwise. This clockwise moment, this anti-clockwise moment. And the condition of equilibrium before the meter is balanced is clockwise moment equals anti-clockwise moments. What are clockwise moments? Moving toward the right, which is mg times multiplied by 51 minus y equals 65 multiplied the anticlockwise moment, 65 multiplied by y minus 22. We have gotten our mg, that's 37.5 into 51 minus y equals 65 into y, 65 into y minus 22. Now let's open the brackets. When you multiply 37.5 multiplied by 51, you are having 1912.5. 37.5 times y, that's 37.5 y equals 65y. 65 times minus 22, you're having minus 1430. Let's collect the like terms. Let's take minus 1430 across the equal sign, change to positive. 1915 plus 1430 equals 65y plus minus 37.5 y across the cos sign change to positive 37.5 y. When you add it together, you're having 3,342.5 equals to 102.5 y. Divide both sides by 102.5. 102.5. Let's cancel this. Therefore, our y equals, when you divide it, you have 32.61 centimeter. That's the value of the y, the distance of the balance point from the zero end. If the body were moved to the 22 centimeter mark instead of 10 centimeter mark, you have the distance of the y to be 32.61 centimeter. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.